Alrighty, let's take a look at question 6. In question 6, we're going to look at how to apply the implicit differentiation procedure in finding the SOT. So you might wonder, what is SOT? Well, SOT means the slope of the tangent line. Alrighty, anytime that you're looking for the derivative at a point, you have to what you're looking for is the slope of the tangent line. They basically are one and the same. All right, so when you're differentiating implicitly, there's something that most students forget, okay? So let's address that real quick. When differentiating implicitly, most students forget to check for agreement and they forget to apply the chain rule where applicable, okay? So recall to check for agreement when you are differentiating implicitly, alrighty? So in this problem, we're differentiating with respect to x. So any term that's in terms of x as a function of x, we have agreement, okay? But if it is any other variable, when we differentiate that term, we have to add d of that variable, the x, to indicate that we do not have agreement, okay? All right, let's go ahead and apply it here. In this scenario, we have x plus, we have 2y to the 1/2. I'm going to write it as 2 root y so I can differentiate quickly, equals y. All right, so when we differentiate the first term x, we have agreement here. The derivative of x is just 1. Okay, you can add on dx, but it cancels out, so you don't have to bother. Now, when you're differentiating this term right here, you're going to have, now this is, you can use the power rule, but I like to use this shortcut right here. The derivative of root x is equal to 1 over 2 root x. So if you have this mastered, it's going to really save you a lot of time. All right, so the derivative of 2 root y is going to be, so factor out the 2 and differentiate root y. You're going to have 2 over 2 root y. Okay? And then, is that it for this term? For the derivative of this term with respect to y? The answer is no. So the mistake most students make is they go on and just say, oh, the derivative of this right here is dy dx, which is incorrect. Since we have disagreement, this variable differs from that. We have to apply the chain rule and add on dy dx because x and y do not agree. The same applies to the right side. The derivative of y is just 1. And then applying the chain rule, because we have disagreement, we'll add on dy dx. Okay. All right, let's make it look pretty. We're going to have 1 plus 1 over root y dy dx equals dy dx. Now what we're going to do is we're going to collect all the terms that have dy dx to one side of the equation and then isolate dy dx. It's like an algebraic process. That's what we're going to be doing right now. All right, so this term 1 root y dy dx, we're going to move it to the right side. All right, so picture subtracting 1 over root y dy dx from both sides of the equation like you normally do in Algebra 1 and 2. If you do that, you're going to end up with 1 equals dy dx minus 1 over root y dy dx. Now we're going to go ahead and factor out dy dx from the right side of the equation so we can isolate it. If we carry out the factorization, we'll have 1 equals, when we factor out dy dx from dy dx, you have 1 minus 1 over root y times the quantity dy dx. Okay. Now we're going to be dividing by this difference of these two terms right here. So let's do this. How about we simplify it first and then we can see what happens. I want to combine these two together. So I'm going to do that on the side right here. If I want to combine 1 minus 1 over root y, what I'll do is I'll multiply both sides by root y. So let's do that. I need to have the same common denominator, so I need to multiply this by root y top and bottom. So that gives me root y minus 1 over root y. That's basically what this difference is. You see why I'm doing that in a second. So if I combine these together, these two, I will have root y minus 1 over root y. Okay, so that dy dx is equal to 1. Okay, so to get dy dx by itself, I need to get rid of this coefficient. So what do I do to both sides? Rather than divide by this coefficient, I can multiply by its reciprocal. So since I have it already combined nicely, I can just multiply by root y over root y minus 1. Okay. All right, so when we do that to the left, we do exactly the same thing to the right to preserve equality. And then we have root y minus 1. And then on the right side, these divide out. Goodbye. Left with 1. And these divide out. Left with 1 also. So we have the slope. Okay, so dy dx, the slope at any point is root y over root y minus 1. Alrighty. So in order to finish this off, we just have to evaluate the derivative at this particular point, 15, 25. So let's do it. So dy dx, we're going to find the SOT, which is dy dx at a point. The point that we are looking at right here is 15, 25. So notice it's dependent on the y, right? So it's going to become root 25 divided by root 25 minus 1, which is going to give us root 25 is 5 over root 25 is 5 minus 1, 4. Answer to question number 6 is 5 over 4. Option letter C. To watch this presentation, to help support our channel, do give us a thumbs up or a like. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel if you haven't already done so. If you have any questions or comments as indicated earlier, just put it in the comment section below and we'll be more than glad to support you. Tons of support resources can be found at mathgotserved.com, all free. Or just take a look on the link in the description below. Thanks again for watching and have a wonderful day. Goodbye.